Hello children, welcome back to another session of digital learning. Today we will be learning a few more concepts related to pair of linear equations in two variables. In part 1 we have learnt how to find the solution of a pair of linear equations in algebraic method. In today's class we will be learning how to find the solution of a pair of linear equations using graphical method. But before we get into our lesson, let us quickly recall our concepts. An equation of the form ax plus by plus c is equal to 0, where a, b, c are real numbers and where at least one of a or b is not 0, that is a square plus b square is not equal to 0, is called a linear equation in two variables in x and y. Let us take an example. 2x plus 3y is equal to 80. Also, a pair of values of the variables x and y which together satisfy each one of the equations is called a solution for a pair of linear equations. Now, let us learn how to find the solution of a pair of linear equations using graphical method. Before that, first let us understand the nature of the graph. The graph of a linear equation in two variables is a straight line, and ordered pairs of real numbers x and y representing points on the line are solutions of the equation. So, let us first understand the relation between the two lines in the same plane. When two lines are drawn in the same plane, only one of the following three situations is possible. The two lines may intersect at one point, just like this. You can see that the lines are intersecting at one point. The two lines may not intersect, that is, they are parallel. I hope you understand the word parallel, children. And the two lines may be coincident. Actually, both of them are same, which means you can observe that the two lines are coinciding with each other. Now, let us understand the relation between the coefficients and nature of system of equation. If we take any two linear equations, then let a1 b1 c1 and a2 b2 c2 denote the coefficients of a given pair of linear equations in two variables. If we start comparing the ratios of the respective coefficients, when we observe a1 by a2 is not equal to b1 by b2, then the lines are said to be consistent and independent. What do we call the lines as? Consistent and independent. And how do they look on the graph? We find that the two lines are intersecting. Therefore, we can have only one unique solution, which means both the lines intersect at only one point, and that point is our solution. When a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, then the lines are said to be inconsistent. So, on the graph we find the pair to be a set of parallel lines. So, we can say that there can be no solution possible for such a pair of linear equations. And when a1 by a2 is equal to b1 by b2, which is also equal to c1 by c2, then the pair is said to be consistent and dependent. We call the lines as consistent and dependent lines. So, when we observe on the graph, we get to know they are coincident. Then we find infinitely many solutions, because we find many points common to both the lines. Thus, we can say that pair of linear equations in two variables are said to be consistent and independent if and only if they intersect at one point, that is a unique solution. And pair of linear equations which have no solution are known as inconsistent pair of linear equations. These are parallel in nature. And finally, pair of linear equations which coincide, then there are infinitely many solutions, each point on the line being a solution. Such pair is called as consistent and dependent. Now, let us quickly check if the following pair of equations represent intersecting, parallel or coincident lines. Find the solution if the equations are coincident. Now, what are the equations given to us? 2x plus y minus 5 is equal to 0 and 3x minus 2y minus 4 is equal to 0. So, let us first compare the ratios. In the equation 2x plus y minus 5 is equal to 0, a1 is 2, b1 is 1 and c1 is minus 5. And in equation 2, a2 is 3, b2 is minus 2 and c2 is minus 4. So, when we are comparing, the ratio a1 by a2 is equal to 2 by 3 and b1 by b2 is equal to 1 by minus 2 and c1 by c2 is equal to minus 5 by minus 4. So, what do we observe? We observe the ratio of a1 by a2 is not equal to b1 by b2. Therefore, we can say that the lines are intersecting lines and hence it is a consistent pair of linear equations. For the equation 2x plus y is equal to 5, first let us find the ordered pairs belonging to this line. So, what are we trying to do? The equation given to us is 2x plus y minus 5 is equal to 0. We are transposing x and 5 to the other side to find the value of y. So, y is equal to 5 minus 2x. So, if our value is x, then y comes out to be equal to 5 minus 2x and our ordered pair would be x comma y. So, if we take x as 0, then y would be, wherever we have x, we are substituting 0 there. So, y would be 5 minus 2 times of 0. 2 into 0 gives me 0. So, 5 minus 0 is equal to 5. So, my ordered pair is 0 comma 5. If I take 1 as x value, then my y would be 5 minus 2 times of 1. So, it is 5 minus 2 which is 3. Therefore, my ordered pair would be 1 comma 3. If I take 2, then my y value would be 5 minus 2 times of 2 which is equal to 5 minus 4, that is equal to 1. So, my ordered pair is 2 comma 1. And if I take x value as 3, then y is equal to 5 minus 2 times of 3, that is equal to minus 1, which comes out to be 3 comma minus 1. And if I take my x value as 4, my y would be 5 minus 2 times of 4 which is minus 3. So, my ordered pair is 4 and minus 3. Now, let us find the values for the second equation, which is 3x minus 2y minus 4 is equal to 0. So, we are transposing the terms to the other side to find the value of y and we get y as 4 minus 3x by minus 2. So, what are the values for xy here? If we take x, then its y value would be 4 minus 3x by minus 2 and our ordered pair would be x comma y. So, if I take x as 0, my y value would be 4 minus 3 times of 0 by minus 2 which is minus 2. So, my ordered pair is 0 comma minus 2. If I take x value as 2, then my y value would be 4 minus 3 times of 2 by minus 2. So, 3 times of 2 gives me 6. 4 minus 6 by minus 2 is minus 2 by minus 2, which is 1. So, my ordered pair is 2, 1. And if I take 4, my y value would be 4 minus 3 times of 4 by minus 2, which is equal to 4, and my ordered pair is 4, 4. If you have observed, children, we are taking multiples of 2, so that we can easily cancel with 2 and find the ordered pair. Now, we have our xy values for the respective lines. Let us try to plot them on the graph. Drawing the x axis and y axis, x dash, y dash, and the point where these two meet is our origin 0, 0. Now, let us plot the points in their respective places. After plotting the points, let us draw the line, and what do we observe? We observe that the two lines 3x minus 2y is equal to 4 and 2x plus y is equal to 5 are intersecting at one point 2, 1, are intersecting at one point 2, 1. So, this is our solution for the given pair of linear equations. So, this is the only unique solution possible. Now, let us quickly check if the following pair of equations is consistent and also verify by a graphical representation. What are the equations given to us? 3x plus 4y is equal to 2 and 6x plus 8y is equal to 4. Now, let us start comparing the coefficients. A1 by A2, we get it as 3 by 6, which is equal to 1, and B1 by B2 is equal to 4 by 8, which is equal to 1 by 2, and C1 by C2 is equal to minus 2 by minus 4, which is equal to 1. What do we observe, children? We observe that A1 by A2, we got it as 1 by 2, B1 by B2, we got it as 1 by 2, and C1 by C2 also we get 1 by 2. So, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Therefore, they are coincident lines. So, the pair of linear equations are consistent and dependent and have infinitely many solutions. So, even before drawing the graph, we are able to tell the nature of the graph, that the pair of equations given to us are consistent and have infinitely many solutions. So, let us first find the ordered pairs. For every x, y would be equal to 2 minus 3x by 4. We are transposing the terms to the other side and trying to find the value of y. So, our ordered pair would be x, y. So, when I am taking x value as 0, y would be equal to 2 minus 3 times of 0 by 4, which is equal to 1 by 2. So, our ordered pair is 0, 1 by 2. When we take x value as 2, our y value would be 2 minus 3 times of 2 by 4, which is equal to minus 1. So, our ordered pair is 2, minus 1. And when we take x value as 4, our y value would be 2 minus 3 times of 4 by 4, that is equal to minus 2.5. So, our ordered pair is 4, minus 2.5. And when we take our x value as 6, then y is equal to 2 minus 3 times of 6 by 4, that is equal to minus 4. So, our ordered pair is 6, minus 4. Similarly, let us try to find the ordered pairs for the second line, which is 6x plus 8y is equal to 4. For every x, its y value would be equal to 4 minus 6x by 8, and the ordered pair is x, y. So, when my x value is 0, y value would be equal to 4 minus 6 times of 0 by 8, which is equal to 1 by 2. So, my ordered pair is 0, 1 by 2. Now, for every x value being 2, my y value would be 4 minus 6 times of 2 by 8, which is equal to minus 1. So, our ordered pair is 2, minus 1. And if my x value is 4, then y value would be 4 minus 6 times of 4 by 8, which is equal to minus 2.5. And our ordered pair would be 4, minus 2.5. And when we take 6, our y value would be 4 minus 6 times of 6 by 8, which is equal to minus 4. Our ordered pair would be 6 comma minus 4. If you carefully observe, children, in both the tables you find the same set of ordered pairs appearing 0, 1 by 2, 2n minus 1, 2n minus 1, 4n minus 2.5, 4n minus 2.5, 6n minus 4, 6n minus 4. So, it is enough for us if we take any 2 points plotting the lines. Let us draw the x axis and y axis, x dash, y dash, and the origin and the respective markings. Okay. We start plotting the points 2n minus 1, 4n minus 2.5. Let us draw the lines. What do we observe? We observe that the two lines are overlapping on each other, that is, they are coincident. They are coincident, therefore, they have infinitely many solutions. And what is the scale we have taken here? X axis 1 centimeter is equal to 1 unit and y axis 1 centimeter is equal to 1 unit. Now, let us check another problem where we are given a pair of linear equations 2x minus 3y is equal to 5 and 4x minus 6y is equal to 15, and if they are consistent or not, and also let us check by graphical representation. So, what are the equations given to us? 4x minus 6y is equal to 15 and 2x minus 3y minus 5 is equal to 0. So, let us start comparing the ratios. A1 by A2 is 4 by 2, which gives me 2 by 1. B1 by B2 is equal to minus 6 by minus 3, which is also equal to 2 by 1. And C1 by C2 is equal to minus 15 by minus 5, which is 3 by 1. What do we observe? We observe A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2. So, the given equations are inconsistent. They have no solution and their graphs is of parallel lines. Let us draw the table for it. For the equation 4x minus 6y is equal to 15, for every x, y is equal to 15 minus 4x by minus 6 and the ordered pair is x comma y. So, when my x value is 0, y would be equal to 15 minus 0 by minus 6, which is minus 5 by 2. So, my ordered pair is 0 comma minus 2.5. So, when my x value is 6, my y value is equal to 15 minus 4 times of 6 by minus 6, which comes out to be 3 by 2. So, our ordered pair is 6 comma 1.5. Let us find for the second equation 2x minus 3y is equal to 5. So, for every x, its y value would be 5 minus 2x by minus 3 and the ordered pair is x comma y. So, when we take x value as 1, its y value would be 5 minus 2 times of 1 by minus 3, which is equal to minus 1. So, our ordered pair would be 1 comma minus 1. When we take x value as 4, y value would be 5 minus 2 times of 4 by minus 3, which is equal to 1. So, our ordered pair would be 4 comma 1. And when we take x value as 7, its y value would be 5 minus 2 times of 7 by minus 3, which is equal to 3. So, our ordered pair is 7 comma 3. Now, let us try to represent these values on the graph. Let us draw the x axis, y axis, x dash, y dash and the origin and the subsequent markings. Then when we start plotting the points, we observe that the two lines 2x minus 5y is equal to 5 and 4x minus 6y is equal to 9 are not seem to be intersecting at any point and they are parallel. They are parallel. When you observe that the lines are parallel and they are not meeting at any point. So, we can say that they are inconsistent and have no solution. For this graph, we have taken the scale of 1 centimeter is equal to 1 unit on x axis and y axis. Okay. I am sure you have understood how to plot the points on the graph sheet and thereby find the solution of the given pair of linear equations. Now let us learn how to reduce the given pair of equations to linear equations in two variables. For an example, we are given 5 by x minus 1 y minus 2 is equal to 2 as one equation, and 6 by x minus 1 minus 3 by y minus 2 is equal to 1 is another equation. These are the pair of linear equations given to us. Now how to solve them? So what are we trying to do? We are trying to reduce the form given to us into a much more simpler form. For that, let us assume 1 by x minus 1 is equal to a and 1 by y minus 2 is equal to b, because in both the equations we find 1 by x minus 1 and 1 by y minus 2 is present. So our equation reduced to 5a plus b is equal to 2 and 6a minus 3b is equal to 1. So let us number them as 3 and 4 respectively. Now let us solve equations 3 and 4 by elimination method, and we are eliminating b here. So the equations we arrived at are 5a plus b is equal to 2 and 6a minus 3b is equal to 1, and we are eliminating b. Now what do we observe? We observe the coefficients of b in equation 3 is plus 1 and in equation 4 it is minus 3. So let us multiply equation 3 with 3. So when we multiply equation 3 with 3, we get 15a plus 3b is equal to 6, and we are multiplying equation 4 with 1 and we get 6a minus 3b is equal to 1. We observe that we have plus 3b and minus 3b, which can be easily cancelled if we add both the equations. So what do we get? We get 21a is equal to 7. So a would be equal to 7 by 21, which is equal to 1 by 3. Now we substitute a is equal to 1 by 3 in equation 3 to find b value. So 5 into 1 by 3 plus b is equal to 2. 5 ones are 5. So 5 by 3 plus b is equal to 2. b is equal to 2 minus 5 by 3. So we get b value as 6 minus 5 by 3, which is equal to 1 by 3. Therefore, we get a as 1 by 3 and b as 1 by 3. But we have to find x and y values. For that, 1 by x minus 1 is equal to a. So we are substituting 1 by 3 in the place of a. Now after cross multiplication, we get 3 is equal to x minus 1. Transposing minus 1 to the other side, we get 3 plus 1 is equal to x. So we get x value as 4. Similarly, we have taken 1 by y minus 2 is equal to b. So instead of b, we are substituting 1 by 3. Again, we use cross multiplication. So we get 3 is equal to y minus 2. Then after transposing minus 2 to the other side, we get 3 plus 2 is equal to y. So we get y as 5. Therefore, our x value is 4 and y value is 5. So children, we have learnt how to graphically represent the given pair of linear equations and what would be the nature of the graph. Let us quickly recap whatever we have learnt. If a1 by a2 is not equal to b1 by b2, then we can say that the pair of linear equations is consistent and independent. We can say that the pair of linear equations is consistent and independent. If a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, then the pair of linear equations is inconsistent and the pair of linear equations is inconsistent. And third condition, which is a1 by a2 is equal to b1 by b2, which is also equal to c1 by c2, then we can say that the pair of linear equations is dependent and consistent. and if the lines intersect at a point, then the point gives unique solution and equations are consistent. If the lines coincide, then there are infinitely many solutions and equations are consistent and dependent. If the lines are parallel, then the pair of lines has no solution and equations are inconsistent. Hope you all understood how to find the solutions for the given pair of linear equations in two variables using graphical methods and what is the nature of the graphs. For better understanding of the concepts, please visit the website of SIET and try the worksheets. That's all for today, children. See you all with some more interesting concepts in the next class. Happy learning. Thank you.